Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 29th of May 2025. This new model claims to outperform existing open source and even commercial video generation tools. The paper is titled MAGREF, Masked Guidance for Any Reference Video Generation. So, the big challenge this paper tackles is creating videos with multiple consistent subjects. Taking pictures of two different people and a specific background, and then generating a video where they all interact believably. The authors propose a new framework called MAGREF that uses a clever technique called masked guidance. This is essentially a way of telling the model exactly which parts of the scene correspond to which reference image. They combine this with a special method to preserve the appearance features of the subjects, and the results are pretty impressive, allowing the model to create complex multi-subject videos even when only trained on single subject examples. And for those of you who want to dive in and try this for yourselves, the authors have already released the official code for this work on GitHub. The repository has everything you need to get started, including inference code, scripts for running on both single and multi-GPU setups, and detailed installation guides. They've noted that the model checkpoints, which are the saved, trained versions of the model you need to actually generate videos, will be released very soon. Alright, and the results really speak for themselves. This first figure gives a great visual overview of what MAGREF can do. On the left you see the reference images, and on the right you see frames from the generated video. The top row shows a single ID example, using a Van Gogh painting to create a video of a man in a cafe. The middle row takes two different people and generates a scene of them painting together, keeping both of their identities distinct. And the bottom example is even more complex, combining a person, a specific cat, and a park background into one coherent video. This flexibility is really the key takeaway here. Of course, to get results like we just saw, you need incredibly high-quality training data, and this next figure shows the impressive three-stage pipeline they built to create it. It all starts with a general filtering stage, where they took millions of raw videos and narrowed them down to the best ones, adding captions. Then, they have two parallel tracks, one for processing objects like a cat or a hat, and another dedicated to processing human faces. For the objects, they use a process called grounding segmentation, which is a way to precisely locate an object in a video based on a text label, ensuring the model knows exactly what it's supposed to be tracking. Alright, so after creating that high-quality data, this next figure shows us the core architecture of the MAGREF model. First, it takes all the reference images, puts them on a single canvas, and runs them through a VAE encoder. This compresses the images into a compact, numerical format called a latent feature map. Crucially, it also creates a region-aware dynamic mask, which is a map that tells the model exactly where each reference subject's features are located. This mask, the reference features, and the noisy video data are then stacked together using channel concatenation, which preserves the pixel alignment before being processed by the main DIT blocks to generate the final video. And this figure gives us a closer look at that region-aware dynamic mask I just mentioned, and contrasts it with a simpler approach. At the top, you see the MAGREF method. It takes all the reference images, the face, the dog, the house, and places them on one canvas. The key is the resulting mask, which has distinct zones that spatially map to each reference. This tells the model precisely where each identity belongs. In contrast, the vanilla mask at the bottom just creates one solid block, which can't distinguish between subjects, leading to identity bleed and confusion in the final video. So that region-aware dynamic mask is crucial for handling multiple subjects, but it's just as important for getting single subject videos right. And this figure shows a gallery of those single ID generation results. In each row, you see the input reference photo on the far left, and then a series of frames from the output video. The model does an excellent job, taking a single image and creating a short dynamic clip that follows the text prompt, like the woman smelling flowers or the man giving a thumbs up, all while maintaining that person's identity consistently. And that consistency is even more impressive when we move from single subjects to multiple, which is what this next figure shows. The challenge here is ramped up significantly. In the top row, the model takes three separate reference images, a man, a German shepherd, and a building, and seamlessly combines them into a video of the man in a park with the dog walking by. The next rows show this with multiple people, first with 2 individuals on a couch, and then with 3 women on a patio, all keeping their distinct identities intact in the final video. Okay, so we've seen some great examples of both single and multi-subject generation. But how does MAGREF actually stack up against other leading models? This figure provides a fantastic qualitative comparison. The input is a photo of Albert Einstein, and a prompt to put him on a motorcycle in the desert. If you look at MAGREF's result in the top right, it's really impressive. It clearly maintains his identity and follows the complex prompt. In contrast, if you look at the other models, many of them struggle with this balance, either losing the distinct facial features or failing to generate the full scene correctly. As we've seen, MAGREF really pushes the boundaries of what's possible in reference-based video generation. The key takeaway is its remarkable ability to maintain subject identity, even with multiple people, thanks to that clever region-aware dynamic mask. This is a significant step toward creating truly personalized and complex video content from just a few images. Well, that's all the time we have for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.